All right, guys, here we go. Let's tackle this. So we're going to work on number one here. Oops. We're going to work on number one. So this is my new, not my new one, but I finally got it working again. Number one, they want you to solve and justify. So when we talk about the word justify, let's tackle that first. So when we solve and justify, our idea is this: to justify, you got to either use graphical, and then from there, you're going to either use numerical or um, algebraic. Okay. So the key here is you've got to justify at least two ways. So we're going to take something like this 5y equals, or is that not equals? Yeah, it's equals. That's 3y. Sorry. Sorry, guys. I need to have my glasses on. 3y equals 2x plus 3. And then we have to solve this thing for y. So we're going to divide everything by this, and we're going to get 2/3. Uh, we're going to get 2/3 x because I'm dividing everything by 3. And that's going to be 1. And you can plug that into the calculator to get your answer there. And then I'm just going to rewrite the second one like this to where it's -4 minus x. And you could rearrange it to make it -x minus 4 if you'd like. Doesn't matter. Either one works. It doesn't matter either way. So then I'm going to go ahead and I'm going to do my algebra. I'm just going to set these two equal to each other. And I'll show you what I do here. So I'm going to do 2/3 x plus 1 equals, and then I'm going to do -x minus 4. And then from there, I'm going to multiply everything by 3 because I can get rid of that denominator. So I get 2x plus 3 equals -3x minus 12. And then I get 5x, and then it's because I'm going to move the 3 over and it becomes a positive, and then I'm going to move the 3 over, it becomes a negative. I get -15, x equals -5. So I've got x equals -5 right there. I'm just going to go ahead and take uh, this one here, and I'm going to plug in -5. I'm hoping I did that right. Yeah, that's negative. That's negative. Yeah, it should be pretty good. I'm going to do that there. And then what I'm going to do is, oh no, that's 3. Sorry, guys, that's 3. I knew something was wrong. So that should be -3. So it's actually x equals -3. So then I'm going to take this, I'm going to plug it back into either one of these. And it doesn't matter which one you plug it into. I'll do the one with the fraction. So then y is going to equal 2/3 times 3, -3, plus 1. Those cancel, and I get 2 plus 1, which is 3. And I don't know if that's the right answer, but we're going to find out. And so that is my answer for the algebraic portion of this. And I'm trying to get my computer to move around here, guys. So, sorry, guys. My computer's freaking out, and I need to get where I need to go here. And all right. So what we do is we take that. That should be -1. What did I get? What did I do wrong here? I did something wrong. I should get -1. Oh, I forgot this right here. I knew there was a negative somewhere. This is still a negative, so that makes that a -2 because just the 3's cancel. So this is equal to -1. So I have an an intersection point of -3 and -1. So then I'm going to do this, and I'm going to go down to -3 and down to -1. And I know they cross there. And then I'm going to use this y-intercept at 1. And I'm going to use this -4, and I'm going to go down to -4. And my graphs should look something, and I can't draw straight lines, but they should look something like that. So that's number one. That's number one right now. So from there, we are doing the next one, which is negative x, y equals negative x plus 3. And we're doing 3 equals negative y. And that's going to be negative 7x. So this one's good. Let's clean this one up here. Uh, so you got a couple of different options. I'm going to move the y over here, which is going to be a positive. And then I'm going to move the 3 over here, which is a negative. And that will be my answer for that piece there. So I've got two different ones here. I got two different ones, and those are my two answers. And so from there, I can set those equal together because I'm going to do the algebra. I like doing the algebra ones to prove my point. And we're going to get negative 7x minus 3. And if I move this over, I get this becomes a positive 7x, so that gives me my 6x. And if I move this over, it becomes a negative 3 minus another 3, because this guy's going to be, and now I get, which is negative 6, excuse me, x equals negative 6, x equals negative 1. So then from there, I've got x equals negative 1, and I'm just going to plug my negative 1 in, and I get negative 1 plus 3 equals y, and that's going to equal 4. So y equals 4. So now I got y equals 4. So now I know my intersection point. I'll redraw it again. My intersection point, and again, you can use the calculator to do this. I'm just kind of lumping it all into one. My 1 and 4. Negative 1 and 4. And then I'm going to use my intercepts. So negative 3's down here like this. And then positive 3's up here like this. So my graph looks something like this right here. And I have justified where they intersect. Even if I use the calculator and draw this, it's going to be right there at negative 1 and 4. So that's kind of how I deal with those. Now, if you, oops, sorry guys. Let's move this up and out of the way already here. So let's go to the next one. And it says y is greater than 1/3 x plus, oops, this is not the right size. And now it's going to be too big. Whoa, freaking out. That's close enough right there. Let's just erase this stuff. All right, let's just move past this point. Nope, darn it. All right, let's try that again. Okay, so we're going to go back to this one here, and we're going to get y is greater than 1/3. Why is it freaking out? Please don't tell me it's going to freak out. Y is greater than 1/3 x plus 3, and then y is greater than negative x minus 1. Now I can graph this immediately because they're an inequality. So let's graph this first one. I got a plus 3, and that's a 1 over 3. So my slope is up 1 over 3. So I've got a thing here, and then I've got my negative 1 slope here. So I've got my negative 1 slope here, and then it's a slope of 1 to 1, so it's going to go like this, like that. And then my graph is going to shade in above it like this. Okay. So my graph's going to shade in above it like that. And so my answer, my question is, does it justify 0, 0 a solution? So it is not a solution because it is not a 0, 0 is not in the shaded area. Okay. And then another way to do it is you just plug 0 and 0 in here. So 0 is greater than 1/3 times 0 plus 3. 0 is greater than 3. This is not true. That's not true. So therefore, it's not a solution. Okay? So those are the ideas behind it. All right. So let's move on. I'm not going to do that other one. So let's move on to this next piece. And I will get you guys going here. Let's go to I'll skip that one. I'll do one later. So then we've got the idea of this one here. I'll do one more. It's already 3 o'clock. It wouldn't work like I wanted it to. So 4y and then minus 4z equals 4. And then we've got negative 6x plus 2y plus 2z equals 10. And we've got negative 3x plus 4y plus 6z equals negative 17. That should be a 10. Negative 17. So then I can take these two equations and I can look for something to cancel out. I'm just going to cancel out the y. So I'm going to multiply this one by 2. So I'm going to leave this one as 4x minus 4y minus 4z equals 4. And then I'm going to take this one, negative 6x plus 2y plus 2z, and I'm going to do a 10. So then I'm going to cancel out the y's. I'm going to multiply this by 2. So this is going to become negative 12x plus 4y plus 4z equals 20. So then these cancel, and I get a new equation. If I just add 4x and negative 12x, I get negative 8x. And I get, oh, look at that. I canceled out a z. Did you notice that? Did I copy that right? Oh, I did. Look at that. I canceled out a z. So the z's cancel. So x equals 24. So therefore, uh, x equals negative 3, which is one of the answers. And then I can take, so I've got an x right there. So now what do I do from there? Now I got to figure out what else I'm going to do. So we know that x equals negative 3. Let's see, how can I find a y here? How can I find a y? So let's tackle the next one here. Let's just do these two together, and I'm gonna multiply this one up here by 2 again. So I'm going to take it's going to be negative 2 this time. So it's going to be negative 2 negative 6x plus 2y plus 2z equals 10. And so I can, at that point, let's see here. So I'm taking this one here and I'm going to get 12x minus 4y minus 4z equals negative 20. Okay, and that's a 12. And then I'm going to keep this one the same. So I get negative 3x plus 4y plus 6z equals negative 17. And then those cancel, and I get 9x plus 2z equals negative 37. Sounds good. But I know that x is negative 3, so negative 27 plus 2z equals negative 37. I move this over, it becomes positive 27, so therefore 2z equals negative 10, and z equals negative 5. So now I've got an x and a z, and so from there, these are long problems. I got an x and a z, so therefore I just can plug it into any one of these. So I'm going to take this first equation right here, And I'm going to do 4 times negative 3 minus 4y minus 4 times negative 5 equals 4. This is going to be negative 12 minus 4y minus 20 equals 4. And then I'm going to move everything over, so I get negative 4y equals 4 plus 12 plus 20. And then I am going to add all this together. That's going to give me 32, 36 minus 4y. And why does this feel like it's the wrong answer? Because it is. Let me go back, guys. Watch out. Let me go back here. That's correct. This is not. This is plus 20. So that means I got to rewrite this. Mistakes with negatives, guys. 4y equals 4 minus. Y should equal. Yeah, that's right. So 4 minus 20 plus 12, which is going to equal, that's negative 8. That's negative 8, so that's going to equal 4. So negative 4y is it going to equal negative 4? No, it's going to equal negative 4. And then y equals 1, and that's my answer. My answer is x equals negative 3, y equals 1, and z equals negative 5. All right, so that's going to be the part 1, guys. So the video is not too long, and I will see you soon.